Hello everyone and welcome to my lesson on recursion. If you're watching this video, I'm assuming that you already know what a method is and what it means to call on a method. If these things don't sound familiar to you, I highly suggest that you click on the link in the description and watch the lessons related to these topics first. So recursion. Recursion is defined as the calling of a method within itself. So if you think back to your lesson on methods, essentially methods are lists of steps or instructions that the computer can follow to calculate something. And recursion is when one of these steps or instructions involves the method itself. So that's a bit abstract, and it would be useful to put it into a concrete example. So here's an example question that we'll work through together. The factorial of a positive integer n is defined as the multiplication of all positive integers less than or equal to n. For example, the factorial of 2 is 1 times 2, which is 2. The factorial of 6 is 1 times 2 times 3 times 4 times 5 times 6, which is equal to 720. Write a program that calculates the factorial of the integer n. So let's think about this question. A lot of you are probably thinking, I could use a while loop for this, or a for loop. And that's absolutely true, and as an exercise, I want you to write a program using a while or for loop that calculates the factorial of an integer. However, for the purpose of today, we want to look at this question in a different perspective. Look at the structure of the calculation this way. You see that the factorial of a number is actually the factorial of 1 less than that number multiplied by the number n. So for example, you're looking at the factorial of 6, and you see that it's nothing more than the factorial of 5 multiplied by 6. And so if we can calculate the factorial of 5, then it's easy to calculate the factorial of 6. But then to calculate the factorial of 5, we need to know first the factorial of 4, and so on and so forth. Do we ever get an answer then? Well, yes, because the good news is we know for sure that the factorial of 1 is just 1. So, let's write our program in a flowchart. We start with the parameter n. We check if n is 1, because that's the easiest case, so let's deal with that first. If n is 1, we say the answer is 1. If n is not 1 though, we say the answer is n times the factorial of n minus 1. So in this case, in the case of n equals 6, we are saying that the factorial of 6 is equal to 6 times the factorial of 5. Then what is the factorial of n minus 1? Well, that's going to start a new call of the function with parameter n minus 1. The same method is getting called on, so n minus 1 equals to 1 will be checked. If it's true, we return 1 for the second call of this method, and that is what gets fed into this red factorial call here. And again, if n minus 1 is still not 1, we do another call for the factorial of n minus 2. And that goes on until we reach 1 for our parameter. So the code would look something like this. The factorial function is defined as follows. If n is 1, we simply return 1. Otherwise, we return n times the factorial of n minus 1. Now, this blue text over here, that is called the base case, and it's the most important thing in a recursion. If you don't have a base case, you'll end up with a recursion of infinite depth. You'll see that this diagonally will go on forever. The base case tells the computer when to stop and when it can start feeding information back up the loop. The red text over here is called the recursive call. Each recursion method must have a base case and a recursion call. That's the lesson for today, and have fun with your exercise questions.